Welcome to Constellations, the podcast from Kratos, where industry leaders share their thoughts and experience on the future of space business, policy, and opportunity. If you like Constellations, please support us by giving a rating and review on iTunes. And don't forget to share this podcast online to help our community grow.
Welcome to Constellations, the podcast from Kratos. My name is John Gilroy, and I will be your moderator. Our guest today is Stewart Sanders, EVP Technology and O3B Empower Program Manager at SES. Stewart, how are you?
Great, thank you.
Well, here we are at the floor of Satellite 2019. You can hear all the people in the background and all kinds of buzz going around here. There's also buzz going around you and your company, you know. There's a lot of buzz about your new constellation. Tell us a little about this constellation and how that fits into the whole discussion here at Satellite 2019.
Yeah, I'm really pleased to be leading this program, and it's something I've been involved in for 3 years now, since its inception. So it's doubling down on what we've been doing in the MEO constellation, leveraging the lower latency of a MEO orbit with Ka-band and exploiting Ka-band at that orbit to provide high capacity, high throughput, low latency services. But importantly, with O3B Empower, we're hooking into the latest technology to fully digitize the payload, give us lots and lots of flexibility, lots of reuse, and a fully beamforming phased array, which means we can generate many, many more user endpoints than we can on the current constellation, over 5,000 per satellite.
Can you give us maybe a little nutshell of this program, the O3B Empower, and how it started and who owns it now and how it really got put together?
So it started within O3B when I was CTO of O3B. O3B is consequently bought by SES, my former company, and SES has put the money behind this. So it's a fully funded program, which frankly differentiates it from a lot of the LEO and MEO programs that we're talking about. It is fully funded, it is under contract with Boeing to develop the satellites, and they are on schedule, despite completely untrue rumours I've been hearing here. We are 100% on schedule, and we're looking at opportunities to actually accelerate the schedule for the benefit of the customers. So the current expectation is launch in 2021, go into service Q2 2022, but we are looking at opportunities to bring that forward. My role now is to really build out the ground systems, user terminals, network, gateway, SOCs, NOCs, etc. And I've got a small dedicated team working on that within SES. It's really good fun.
Tell me more about the satellites themselves. Why are they different?
So anybody that's seen a traditional geosatellite, there's a lot of hardware. They're big beasts. They wouldn't fit in, the average living room of a house. They're that big, and then you have enormous solar arrays hanging off the side. Some of the HTS satellites I'd worked on not too long ago were talking about 900 up converters, down converters, 1,000 switches, physical metal switches, and so on and so forth. So a lot of hardware pieces to fit together, and a lot of weight, a lot of mass, a lot of size. This satellite is based on fully digitized payload, which basically everything in the chipset, which sits behind the phased array element. It's a very small antenna relative to its capability. It's roughly a meter by a meter by a half a meter. Looks like a box. It's not particularly sexy from that viewpoint, but it packs a heck of a punch.
Boy, I'll bet.
We set some targets when we went to market for this. We didn't issue an RFP. We simply said these are the challenges that we're trying to solve. So each of the satellite vendors, can you give us your best shot? Great response. Huge problem for us because we now have 7 very different solutions to look through and try and figure out which is the best one. And we realised that Boeing had the best. And they've actually we've hooked into the next generation of their payload processing, which is at a speed now where it can direct sample at RF, and the next phase of their phased array development, which is full beamforming. Those two brought to market for a commercial operator. I think it's the first time that level of capability has been brought to market.
If we just grab some random person walking by in a suit and tie and we said, hey, do you know General Pete Haney? Yeah, and they're probably going to say, well, yeah, they're going to say GEO and 150 satellites, and that's what some people think SES is all about. And you've elected to go with MEO, MEO. Why MEO, and how's that helping?
Well, we're not electing to go with one over the other. They both have a place to play within SES's growth going forward. And in fact, we're the only operator operating commercially at MEO, and we're the only operator operating with a combined MEO-GEO capability. And our intent is to offer that combined capability to the market. Some customers will be better suited to a GEO environment. Video distribution, for instance, logically makes sense to go through a satellite fixed in the sky so that you've got lots of direct-to-home antennas pointing at it. It's got reach, and it just makes sense to do that for them. But for data services where low latency is a major factor in the performance of the services, going to MEO makes sense. And leveraging Ka band at that orbit altitude, we can provide very high throughput. Put the two together and provide the network topology to really leverage the two together. We think we've got not just differentiated but world-beating capability going forward.
World-beating? Well, I'd like to hear that.
Yeah, yeah.
You know, when I look at your system and I try to look at it from a distance perspective here, I think you're going to deliver your product without a gateway infrastructure and any kind of corresponding terrestrial overlay from a gateway. How's that work?
So it's not without gateways. We have gateways. Part of the work we're doing here this week is to meet with gateway vendors, specifically around the antennas initially, but we're also planning out where the 8 core gateways will be. And a lot of the data that we push across the O3b Empire system will be going back through those gateways. Those will also be used for the command and control of the network. However, what we can also do with this network is a customer doesn't have to use a gateway. And in fact, any terminal can be conceived effectively as a gateway. We can generate per satellite over 5,000 individual endpoint beams, and then each of those beams can be connected on a channelized basis in any configuration we choose. So if a customer wants to push some of his data to one of our core 8 gateways, he can do that. Equally, if he wants to bring it back into country or go to his own gateway, we can do that as well. So it gives an enormous amount of flexibility. We've seen requests from customers to do these kind of things, and that's one of the reasons that we've driven this into the design of O3b Empire.
Going from the satellite itself to the constellation, I've read that there's going to be 30,000 fully shapeable and steerable beams that can be switched in real time. So what do you mean by shapeable here in this context?
So a phased array can generate anywhere from 1 to a very, very large number of individual beams, and each of those beams can be weighted or shaped to any configuration we choose. It's just the nature of the technology. It's a mathematical algorithm that drives the elements to produce the shapes, the far-field shapes that you want. Now, logic says that the optimal performing beam shape is going to be an elliptical or close to circular beam, and that's generally what we will offer. But we do have the capability of defining more irregular shapes where it makes sense, maybe to cover a constellation of end-user points, for instance.
So will this be a software-defined shape, a software-defined network, or software?
It's an ability on the ground to drive how the chipset on the spacecraft is performing to build that far-field waveform through the phased array. Yeah.
Well, here we are in Washington, D.C. Across the river, there's the Pentagon, and I look at a steerable beam. Would that be of interest to government users?
Yeah, for sure.
Maybe even the military as well, huh?
Yep. Yeah. We're getting a lot of traction across all of our segments, and I don't want to single out the government alone to be the one that's most interested in it, but of course they're interested. We have the ability to provide fulfill use cases that I don't think they've been able to see before from satellite vendors, and that's something we're busily discussing with them and other segments for sure. So it works for fixed data because it's low latency, high throughput. It works for mobility because we have that complete flexibility to steer the beams in any configuration that the customer wants, and optimized for the individual customer that, based on the antenna size they're using at the far end.
from an antenna perspective, will they need specialized antennas to receive that?
No, there's no difference than the antennas that we are currently using on O3B current. They have to be able to track the MEO constellation, but we already have those terminals rolling out. All of the terminals that are on O3B current will be fully forward compatible with O3B mPOWER, but we will be bringing new products and terminals to the market over the coming years as we go into service. It's a great opportunity, partly because we can operate higher throughputs to lower terminals than we can on O3B current. The link budgets are improved, but it's also because the satellite constellation itself will enable many, many more types of service, and a lot of them may be thinner throughput than we've traditionally done with O3B current.
Stewart, I know you live in Europe, and believe it or not, thousands of people from all over the world, even Europe, listen to this podcast. If you are listening now and would like to get alerts when new episodes are available, simply go to Google and type in Constellations Podcast, and Kratos will be right there and it'll sign you up. When I was doing research for this interview, I came across a kind of a strange phrase. I don't know if it's applicable or not. The phrase is intelligent software. And so is this artificial intelligence or intelligent software? What does this mean to your application?
So it's something SES has been, I think, quite forward-thinking. And we already have a contract with IBM Watson. We're going to use it for part of our command and control, spacecraft command and control infrastructure, specifically to look at spacecraft telemetry in a more intelligent way. And it's the intelligence in the software is that you can teach it to do things in an automated way, and it learns effectively from... You have to spend a lot of time in framing how it does that, but effectively it can learn what it needs to do, and it will reduce the overheads of what we need to do. One of the key pieces for O3B mPOWER is something called the System Dynamic Resource Manager. We have an awful lot of capability in the spacecraft where they're generating so many beams. We are going to contract for very, very shortly a System Dynamic Resource Manager, SDRM, and that will allow us to determine what the right throughput, beam shape, beam pointing for each customer is based on a number of factors: what the customer is drawing in terms of throughput at a particular time, where they are, if they're a mobility user, because as they move we can update the beam pointing. But there is a place for intelligence software in that, and we have been working with MIT for a while. We're funding some development work at MIT on 2 specific projects, and one of those we fully expect to see some output which we can plug into this SDRM concept in the coming years. That will help in later years with dealing with contention as we fill up the satellite, as we expect to do, to optimize the performance for the customers and for the resource itself.
When you think about dynamic allocation of resources and using some powerful artificial intelligence to accomplish that, and then you apply that to something like virtual fiber networks, talk about flexible. No wonder you're talking about thousands and thousands of beams. And I mean, this just gives you all kinds of flexibility that no one ever dreamed of that before.
That's right. And it is easy to get lost in the complexity of this, but I like to frame it in a vision of something in the future, and that's a vision where a customer of ours can go onto a web portal, order a service through the web portal, and choose what they want that service to do. They want to connect certain geographic locations over a period of time. Maybe some of them are mobility. They want to choose some features around those services. Maybe they want some caching. Maybe they want encryption. Maybe they want analytics. They want that service to last for a period of time, which they can define, and they press a button and it's self-provisioned. And the network itself will provision that, or orchestrate the solution, and it will move the customer's data on a bit-by-bit basis as that data can best be moved across the network in terms of what that data needs. So if it doesn't require low latency, it can go one route. If it requires does require low latency, it can go another route. But there's an inherent intelligence to that kind of network, and what we will see more and more is the integration of the space segment with the network segment, business applications. So a customer doesn't need to care about the fact that they're moving across a satellite constellation at all. It's just another piece of infrastructure, but it's a very sophisticated piece of infrastructure. That's where we're heading.
In doing research on your project here, I've read a couple things that you've written, maybe someone else has written. They talked about end users becoming creators of content. What does that mean?
So anybody that's got kids knows just how much they're generating, Facebook input, etc. I think if you look at a lot of HTS satellites that have been built recently, they're very optimized for a forward dominant link, i.e. they're pushing more data towards the user than the user is pushing back. And that's because traditionally people have been using these links for pulling video down, podcasts, whatever, streaming data, etc., etc. But there is a trend, it appears, to the individual user generating more data, and that balance between forward and return is moving in some instances more towards symmetry, and in some segments we have segments that will be more return dominant, i.e. the end user will be pushing more data than they're taking. We think that we have, again, a differentiation with O3b mPOWER. It's a bent pipe technology. It doesn't require a particular terminal to interact with it, and it will support any ratio of forward to return mix. It's not optimized just for one segment, and therefore has a lot more flexibility in the segments it can serve.
I want to dig a little deeper into the differentiator here with your offering. Is it using a KA and KU band as well? Is that a differentiator with your particular network?
So we're just using KA band, and the reason for that is we feel it was the best band to use for the MEO constellation exploitation for O3b current, as we're now calling it. But if you talk about differentiation, even before you get into the technicalities of what we're doing, we're funded, we're in business, we have customers up on a non-GSO platform. We're the only commercial operator that does that, and we're the only one that combines it with GEO. I think that's a heck of a lot of differentiation.
I think only ONLY, that's the differentiator here. It's like, name another one that does it. Only.
Yeah.
So what is a customer edge terminal?
So it's a device that sits at the edge of the network that is assigned to a particular customer, and what we're looking at doing, not just in the terminal but edge computing in general, is to integrate the network with the space segment topology so that we can bring a higher level of computing capability to the customer, so that yes, they may be cloud connected, but they don't necessarily need to reach right back into the cloud to do whatever it is they need to do, whether it's analytics, whether it's running some application, and working with partners to extend that cloud connection to provide that kind of capability at the edge. It is a mix of intelligent terminals, but it's also just edge computing as part of the network stuff.
Crystal ball time here, Stewart. Where do you see the future of the MEO constellations going? 4 to 5 years out, where do you see this whole business transforming itself to?
Well, my intent for what we're doing is to double down on the bet we've already made and just keep growing O3b mPOWER, but augment it. We're already looking at what we can do for higher latitudes, bringing in inclined, looking at an inclined equatorial MEO combined with GEO combination, combined with a very developed network topology. That's a really impressive infrastructure going forward, and I think it's going to bring next generation capabilities to the market, and that's exciting.
Stewart, unfortunately here we're running out of time. Now, if you're listening to this and there's snow on the ground and you're trying to figure out what we talked about, you want to type this into Google. It's O3B, then M as in Mary, mPOWER program, and get all kinds of information on it. Sometimes British accent, American accent, we kind of throw these things out, O3B mPOWER, and people can't find it. But that's the best way, O3B, M as in Mary, Power Program. I'd like to thank our guest, Stewart Sanders, EVP Technology, and O3B mPOWER Program Manager at SES. Thank you, Stewart.
Thank you very much.
Thanks for listening to Constellations, the podcast from Kratos. If you like this interview, please subscribe, tell a friend, and give us a review.